Hello students, welcome once again, and in this section we are looking at the trapezoidal rule, Simpson rule, and also Bode rule. Now we are to approximate the integral using trapezoidal rule, Simpson rules, and Bode rule. But first of all, we have to know what the trapezoidal, the Simpson, and also the Bode rule is. Now um is a rule which is normally used for approximation. So when so we're given this, right? So um we're given f of s. So let's say the integral here 3 cube root of x, right? So I'm given the cube root of x here. Now for trapezoidal rule, so the trapezoidal rule, from the trapezoidal rule we have the integral, let's say b to a f of s. The x here is given by h, which is the step size, right, divided by 2. Then we have the f of a here plus the f of b here. So realize that in this case the f of s here is just the cube root of x here. Now that is the trapezoidal rule, where h here is the step size is given by b minus a. Right, now let's talk about the Simpson rule. Now the Simpson's rule here is given by the integral. We have b and a here, f of x here, the x here being equal to h over 3. H is the step size. Then we have f of a here plus 4 of f of c. Then also we have f of b also here, where h here is given by b minus a here divided by 2. But then also the c here is also given by b plus a here divided by 2. Remember, a and b here are just the limits of the integral here, right? So the c, which is the Bode rule, here is given by you have the integral of b and then a. So so over here let's call it s5, and let's call this one x1. F of x here, the x here will be equal to, we have h here over 45. Then also we have so for the Bode rule, it goes this way. We have 14 of x1, then we have 64 of s2, then we have 24 of s3, then we can have 64 of s4, then also we have 14 of x5. That's basically the Bode rule, and h here in this case is given by b minus a here, right? So in this case we have s5 and x1. So in this case h here is given by s5 here minus x1 here divided by 4, right? So now with these formulas over here, we're going to use these formulas over here to solve each one of them. So let's talk about the trapezoidal rule. So from the trapezoidal rule, remember we said is given by this, right? So what we are going to do is that we have h here. H here will just be b minus a, but from here we have our limits are 0 and 3 here, right? F of x here, so f of x is just 3, and then the cube root of x here, the x here will be equal to our h. H is just b minus a, and what is b? In this case b is 1, a is 0, so 1 minus 0 is just 1. So we have 1 here divided by 2, right? And we have our f of a, which is just this. So we have that, and we are putting a in this case is 0 here, right? Then plus the cube root of b, and b here is just 1. So when we sum this, we are just going to get we just have 0 plus 1, which is just equal to half here. So that will be for the trapezoidal rule. Now when we do the Simpson rule, then we are just going to get So B here is just the Simpson's rule. So Simpson's rule, we have the integral 1 0 the cube root of x dx here being equal to, remember from the Simpson's rule we have h over 3, where we said in this case h here is given by b minus a, so we have 1 minus 0 divided by 2, which is just half. Then also we have c here to be b, which is 1 plus 0 divided by 2, which is still half, right? So which means that when we substitute this into it, then which means that we are getting our h here is just 1 over 2, so it's just going to be 1 divided by 2 multiplied by 3, which is just 1 over 6, right? So I'm just going to get 1 over 6 here. Then so 1 over 6, then we have the cube root of f of a is just 0. Then we have 4 of multiplied by the cube root of c, right? So c in this case is just we had c here as half, so c here is just half, put the half here. Then we have the cube root of that of b, which is just 1. So you know we're just going to get 1 over 6. So 1 over 6 here. Then we have computing this, we have just 4.1748. Then when we multiply them together, we just have 0.69580, right? 0.69580 that of the Simpson's rule. Then for Bode's rule, we have the Bode's rule here. Remember, it's just x5, right? So in this case we have to calculate for h, right? H here is given by b plus a. Remember we said the Bode's rule over here is h minus that, right? It's h minus that. So we have h minus a here divided by 4. So our x5 minus x1 basically. So we have this to be 1 minus 0 divided by 4, and we have 1 over 4. So we can get possible values of x here, right? So the possible values of x we can get here is just we can have 0, 1 over 4. We can also have 1 over 2, then we have 3 over 4, then 1. So these are the values that we are going to get. So over here the integral here starting from still 1 to 0, so we are starting from 0 to 1, right? And we have the cube root of x dx here being equal to, we have remember h over 45, right? But because h here is just 1 over 4 multiplies 45, and we have just 1 over 180. So over here we just have 14. So we have 14 here multiplied by the cube root of, we are starting from 0 plus 64 here multiplied by the cube root of just 1 over 4, which is just the next one. Then we have plus 24 here multiplied by the cube root of 1 over 2 here, plus 64 here multiplied by the cube root. So the cube root, we have the cube root of 3 over 4. Then also we have plus 14 here, then multiplied by the cube root of 1. Now when we compute all of these, then we should get this to be equal to, so we have this will be equal to 1 over 180, and when we add all of this together, then we are going to get 131.514, and when we multiply them together, then we're just going to have 0.73063, right? Now you realize that for the Bode's rule, you can see that Bode's rule gives the best approximation, because over here we have 0.73, we we have 0.69, which is more or less, so we just 0.7, and over here we have 0.5. So realize that Bode gives the best approximation. So thank you very much for joining me in this section, and I'll see you in another section.